Greetings. This is Dr. Arthur Smythe, and welcome to Lesson 8.5, Gravity. This lesson will introduce you to gravity and how gravity affects falling objects. The duration of this lesson is approximately 15 minutes. By the end of the lesson, you should be able to describe how Earth's gravity and air resistance affect falling objects. Describe the path of a projectile and identify the forces that produce that motion. Before proceeding, please take out something to write with and something to write on. You will find these notes helpful during assignments, activities and assessments. Gravity is an attractive force that acts between any two masses. The gravitational attractive force's intensity is proportional to the mass of an object and its distance apart. Earth's gravity pulls down toward the center of Earth. Remember, Earth's gravity is 9.81 meters per second squared. For comparison, gravity on the Moon is 1.62 meters per second squared. The gravitational force on Earth is 6 times greater than on the Moon. If you weigh 125 pounds here on Earth, you'd weigh just under 21 pounds on the Moon. Gravity can act over large distances, but it does diminish with distance. Theoretically, however, it is never zero. The Earth and its Moon are 384,402 kilometers apart, yet the Moon's gravity is enough to cause tides. The attraction between the Earth and Moon also acts as a counterweight, allowing our planet to have a consistent rotation on its axis and revolution around the Sun. All this because of gravity. Earth exerts an attractive downward force on this cup. Conversely, the wall exerts an upward force on the cup. Since the forces are balanced, the cup sits until some other force acts to unbalance it. You pick up the cup to take a sip, for example. Think of what would happen if your chair or the floor beneath your feet did not push back. We would all sink into the planet. This is a basic introduction to Newton's third law of motion. We will address Newton's first and second laws of motion in Lesson 8.6. Both gravity and air resistance affect the motion of a falling object. As objects fall to the ground, they accelerate until they reach terminal velocity. Terminal velocity is the constant velocity of a falling object when the force of air resistance equals the force of gravity. This base jumper takes advantage of air resistance caused by his glider suit, to slow its fall and increase the distance covered in the jump. Click on the image to see this exciting pastime in action. A thrown ball follows a curved path. The combination of an initial forward velocity, and the downward vertical force of gravity, causes the ball to follow a curved path. Air resistance and gravity are the only forces acting on a projectile. And if the horizontal velocity of the ball is small enough, air resistance is negligible. Projectile motion is a falling object's motion. A projectile, after it is given an initial forward, horizontal velocity. Another type of projectile motion is if you toss a ball straight up into the air. This simple childhood pastime is actually physics in action. The ball travels upward, using the initial force to overcome gravity, until gravity wins. Then the ball returns, as gravity acts on the ball, pulling it back to Earth. Interestingly, the ball's speed when you catch it is the same as when it left your hand. Between 1589 and 1592, the Italian scientist Galileo Galilei, at that time, professor of mathematics at the University of Pisa, dropped 2 spheres of different masses from the Leaning Tower of Pisa. The purpose was to demonstrate that their time of descent was independent of their mass. According to the story, Galileo discovered through his experiment that the objects fell with the same acceleration, proving his prediction true, while at the same time disproving Aristotle's theory of gravity, which states, incorrectly, that objects fall at speed proportional to their mass. Next, physicist Brian Cox uses the world's largest vacuum chamber to recreate Galileo's legendary experiment. Lesson summary. Gravity is an attractive force that acts between any two masses. Terminal velocity is the constant velocity of a falling object when the force of air resistance equals the force of gravity. Projectile motion is the motion of a falling object after it is given an initial forward, or horizontal, velocity. Air resistance and gravity are the only forces acting on a projectile. All objects fall at the same rate, regardless of the mass of the objects. By now, you should be able to describe how Earth's gravity and air resistance affect falling objects. Describe the path of a projectile and identify the forces that produce that motion. If I have seen farther, it is by standing upon the shoulders of giants. We hope you enjoyed this lesson.